Dear students, welcome to video tutorial on basic properties of nucleus. We all know that nucleus is a very small central part of an atom. In general, the dimensions of the atom are in the range of angstrom, whereas the dimensions of nucleus are in the ranges of femtometer or fermimeter. Coming to the constituents of the nucleus, in an atom, as electron revolve around the nucleus and entire positive charge is concentrated inside the nucleus, we have all the protons and neutrons inside the nucleus and electrons, the negatively charged particles, revolving around the nucleus. So the properties, when we consider the properties, we have to consider the neutrons and the protons. First property is nuclear mass. As we have discussed just now, the constituents, the nucleons are protons and neutrons. So nuclear mass will be the summation of masses of protons and neutrons. We know that for any atom with atomic number Z and mass number A, there will be Z number of protons and A minus Z number of neutrons inside the nucleus. Hence the mass of the mass of the nucleus will be equal to Z into mass of the protons plus A minus Z into mass of the neutrons. In general, the mass of the nucleus is expressed in terms of atomic mass units. Nowadays, it is expressed in terms of unified atomic mass units, either in AMU or in U. One atomic mass unit, that is 1 AMU or 1 U, is equal to 1/12 of mass of carbon 12 nucleus. So that will be equal to, numerically it is equal to 1.6 into 10 power minus 27 kg, or in terms of energy it is equivalent to 931.48 million electron volt. Now the next property, that is nuclear charge. We know that all the positive charge resides inside the nucleus, and the charge on each proton is equivalent to charge on a electron, but a positive sign, that is charge on each proton will be plus 1.6 into 10 power minus 19 coulomb. Hence, if a nucleus has Z number of protons, then the charge of that nucleus will be equal to Z times 1.6 into 10 power minus 19 coulombs. For example, hydrogen atom has single proton, whereas helium atom has two protons. Hence, the nuclear charge of hydrogen will be 1 unit, or it is simply 1.6 into 10 power minus 19 coulomb. Whereas for helium it will be twice of that value, that is 3.2 into 10 power minus 19 coulomb. The next property is nuclear radius. We know that volume of the nucleus will be directly proportional to atomic number A. Since the volume is given by 4 by 3 pi r cube, which will be proportional to A, or we can simply write as r cube is proportional to A, or r proportional to A power 1 by 3. If we remove the proportionality constant, we get a if we remove the proportionality symbol, we get a proportionality constant, that is r naught. Hence r naught, r is given by r naught times A power 1 by 3. The next property is nuclear density. We know that density is given by nuclear mass by nuclear value. Just now we have discussed that nuclear mass is equal to A times the mass of proton. Hence, the nuclear density is given by, look at this formula. Nuclear density is given by A times mp divided by 4 by 3 pi r naught cube times A. If we cancel A in the numerator and the denominator, we remain with mp by 4 by 3 pi r naught cube. If we substitute the values of all these things, then we get the value of nuclear density as 1.816 into 10 power minus 17 kg per meter cube, which is a constant value. It means that irrespective of size of the or number of protons or number of atomic number, the density of the all nuclei remains constant, which will be in the order of 10 power 17 kg per meter cube. The next property is nuclear spin. We know that proton and neutron have angular momentum just like electron, which is referred as spin. The resultant angular momentum of the nucleus is equal to sum of the spin and angular momentum of all nucleons within the nucleus. The nuclear spin is generally represented by letter I, capital I. Hence, nuclear spin I is given by sum of angular momentum, that is IL, and spin momentum, that is IS. The next property is magnetic dipole moment. In spectroscopy, we have studied that a spinning electron has some magnetic dipole moment because of its charge, which is known as Bohr magneton, and its value is given by mu b is equal to EH by 4 pi me, or it can also be written as EH cut by 2 me, where me is the mass of the electron. In a similar way, proton has positive charge, and due to its spin, it is going to have magnetic dipole moment. Similarly, though neutron is chargeless, it has subparticles which will have charge. Though the total charge of neutron is 0, the subneutron particle will have the charge which revolve around the common point, because of which even neutron also has some dipole moment. The nuclear dipole moment is given by Eh by 4 pi mp, where mp is the mass of the proton. This mu n is known as nuclear magneton. It is the unit of nuclear magnetic moment. It gives how much magnetic moment does the nucleus have. The last property which we will discuss is quadrupole movement. This is electric quadrupole movement. The electric quadrupole movement gives the information about the shape of the nucleus. If nucleus assumes the shape of sphere, its quadrupole movement will be 0. But whenever the quadrupole movement is non-zero, then the nucleus shape will change into spheroid as shown in figure. We get two types of spheroids. One elongated along the x-axis, which is called as oblate. The name of the shape is called as oblate, shown by the middle figure on the screen. Similarly, if it is elongated along the y-axis, it is called as prolate shape. Okay, and the electric quadrupole movement is having mathematical formula as 2 by 5 z times E times b square minus a square. From the equation we can say that whenever A is equal to B, Q will be 0. That is, quadrupole movement will be 0 whenever nucleus assumes spherical shape. So these are the properties of nucleus. Let us have a quick revision of the properties. The first property is the nuclear spin, mass. Second one, nuclear charge, radius, nuclear density, nuclear spin, magnetic dipole moment, and the final one is electric quadrupole moment. Thank you.